This conference will now be recorded.
Yes, good morning everyone. Screen and audio both are fine or not, please confirm. Online students, screen and audio both are fine or not, please confirm. Okay. So as you know, this is you are here for physical design demo session, right? And before I start, usually I will ask, so you are from which pass out year, right? So you are recent pass out or you are passed out 2 years back, 3 years back? Can you just answer me, online and offline? How many of you are recent last year pass out? Okay. 20, 26, 25, 24, 23, 2, 1 years, 26, recent only. Okay. Online, how many of you are recent? Can you just mention pass out year? And how many of you are PhD holders? MTech? How many of you are MTech? BTech? Obviously, right? Okay. 2026. So recent only. 25. Okay. Fine. So majority of you are recent pass out. Anyone from MTech? Okay. Fine. Good. So most of you have just passed out your graduation, right? So you might have heard about physical design from someone or from website or some other social media, right? I don't know what you have heard, but I want to tell or I want to ask, what is VLSI first, right? As you know, physical design is part of VLSI. So before starting physical design, right, or before telling you something about physical design, I would like to share, right, that what is VLSI. Can anyone answer this? What is VLSI? Okay, Monica, that's fine. We will discuss and I'll answer all the questions, all the doubts. I'll clarify everything, right? So before that, I'll just brief you about course and the course structure and what we are going to learn and how we are going to learn. Also, how we are going to place all the questions I'll be answering. Then I'll take all your questions and I'll be clarifying each and every doubt, whatever it is. Okay. So before starting, let us get along with what is VLSI. What we are going to learn, that is more important, right? See, whether we are going to be placed somewhere or what skills we are going to develop, that is all secondary. But what we are going to learn is important. That is the first step. So what do you know about VLSI? Anyone?
Very large scale integration.
Very large scale integration.
Yes,
What does
sir.
this mean? Very large.
Uh, Number of transistors on a single silicon chip, sir.
Number of transistors on single chip.
Yes, sir.
Is it correct to say? integrated many number of, that's right. Anything else we should add up? That's correct. Whatever you are saying, that is absolutely correct. Something we are missing, right? What is that? So it is nothing but an integrated circuit only, right? It is, in other words, we say that it is an integrated circuit, but in a very large scale of integration of transistors. Transistors on what? Silicon chip, to develop what? Circuits, right? Designs. Now, how you can fabricate or how you can design in that very large scale? Now, when we say very large scale, what does this very large scale means? How much? Very billions of transistors, right? So it is that, it is what we understand, that it is in that level of integration. Now, how that is possible? How you can fabricate billions of transistor in a small chip, right? What is the size of chip? What is the size of chip? Is it size of chip, or we say it is a millimeter, right? In millimeter we are talking. So nanometer, what you are telling, that is technology node, right? So if we say there is a silicon wafer, right? Size of a chip is not more than your fingernail, okay? Or sometimes half of your fingernail also. It depends on what. Now the complete size of chip is what? Your size of your fingernail or half of your fingernail. Now how billions of transistors are going to fabricate on that size, on that area? How you are going to fabricate it? How it's possible? Now you are seeing in your mobile phones, right? You have processors. Processor is nothing but a chip, right? It is a not macro chip, it is a nano chip. Now how it is possible to fabricate billions of transistors? How? Anyone? How it's possible? For that, the transistor must be in nanoscale. It should be in very, very small. How transistor will become very small? Can you name any transistor? Type of transistor. What type of transistor you know? BJT and
FETs, sir.
MOSFETs, right? So now BJT we call it as current control device, right? And FETs are voltage control device. Whether we can fabricate BJT on silicon, for that we should question first that whether BJT is in that nanoscale or not. Is it realizable? Realizable means what? Can we have it in the physical form in nanoscale? Of course not. BJT cannot be transformed into a nanoscale. Then we came up with FETs. Yes, FET's size can be shrinked to some scale. Okay. So earlier we have FETs 180 nanometer, right? Or or we say 45 nanometer, 90 nanometer, right? What are these? These are called as technology node. So when we say technology node, it is nothing but we say there is 180 nanometer, 90 nanometer, right? Or 40. What does these all nanometer means? What does this technology node means? So transistor, we say FET. Now which FET? That is also important question. Which FET we are going to use to fabricate billions of transistor? MOSFET. Why MOSFET? Why not JFET, or why not other FETs? Because of same reason, that it can be realized into very small size, right? Now how small? So these are some examples, right? Now MOSFET, you are saying, what is MOSFET? Metal oxide semiconductor FET. It is nothing but a sandwich. Sandwich means what? Now you have two bread slices and your cheese in between those two slices. So what is a sandwich here? Metal, that is poly, right? Metal, that is poly. Then comes oxide layer, yes, silicon dioxide layer, and then comes silicon. That is channel formation will happen, right? So this is nothing but MOSFET. Sorry, not here. Okay. Now this is diffusion layer. This is also diffusion layer, and this becomes your MOSFET, and this is your silicon, right? This is your oxide layer, silicon dioxide. This is your polymetal layer, right? And this is your silicon, and you will have channel formation here, silicon, right? So metal, oxide, and silicon, MOS. Understood? So this is called as MOSFET. Now why, so how, when we tell 180 nanometer, what does this mean? Size of a transistor. It is also called as feature size. Now which feature it is defining? Channel length. That is absolutely correct. So we are saying when we say 180 nanometer or 90 nanometer, it is channel length, right? It is nothing but channel length. Clear? So it is nothing but a channel length. Now, if your so how come the transistor size will reduce if you reduce the channel length? Because how come transistor size will change? Because it depends, the size of transistor depends on beta factor or the ratio, W by L ratio. We say W by L ratio will change if your channel length changes. Size of your transistor will change. This is your transistor 2D or 3D. It is a 3D device, right? Transistor is your 3D device, right? This is your diffusion layer, oxide, poly, okay? So this is N plus. So what is this type of transistor called as? NMOS or PMOS? NMOS, right? Why? Because it is heavily doped by N diffusion material, N material, N type material, right? Now this is poly. So this part is called as width, width of a device, and this is called as length. If we change length, so this will also change, width will also change. We have to change it. That is called as beta ratio or beta factor. If you might have studied in CMOS subject, beta factor. What is beta factor? We say we follow basically 2:1 ratio, right? What does 2:1 ratio means? Means if your length is 1, it should be in factor of, width should be in factor of 2 times of length. Why this happens? So it is part of fundamentals of CMOS. It basically we try to equalize rise time and fall time. That is what. Why? So this is followed for what? CMOS, right? Why we want to equalize rise time and fall time in CMOS? What is CMOS? Complementing metal oxide semiconductor. Whatever metal oxide is giving us output, we are complementing it, means reversing it. If I am getting output 0, I am complementing it to 1. If I am getting output as 1, I am complementing, sorry, input as 1, I am complementing it to 0. It is called as inversion, inversion effect. So all the CMOS designs gives inversion effect. When we say CMOS, right? So basic simple inverter is nothing but Y A bar, right? So if we try to just design this, right? This is our PMOS, NMOS, supply, right? And this is our output. If you give 0, what you will get? 1, right? If you give 1, you will get 0. What it is doing? Complementing. right? That is why it is called as CMOS. It is having all the CMOS design have inversion effect. Now we take what? NAND. How many transistors are required for NAND? NAND. Y A dot B bar. So how many transistors are required? 4. Is it correct or not correct? 4 or 6? Okay, so we'll go by 4 only, right? First we'll go by 4. So how many transistors in NMOS structure? 2 transistors, right? This is what? ANDing effect. Now if it is in parallel, it will give ORing effect. PMOS, if it is in parallel, it will give what? ORing. This all will be taught in basics. Don't worry about this. A, B, A, B, supply. So what will happen? What is the AND of A dot B? A dot B is nothing but ANDing. A dot B is ANDing, but it is in CMOS design. So you will get what? Complementing effect, inversion effect. So you will get what? NAND. Right? Now I want to get AND from CMOS design. What I have to do? So already it is in inversion effect. I need to reverse it. So I will add one inverter at output side. So how you will add? You'll connect with this CMOS. So you will get what? And here, A dot B. That inversion effect will get cancelled out. Understood what is CMOS actually? CMOS is nothing but all the design gives inversion effect. Right? Now, so we know that. So this is what? PMOS structure. The pull up we say, right? This is what? PMOS structure. And this is what? NMOS structure. Okay. So for this only we follow beta factor, that width should be in ratio of 2:1. If you have width in terms of 1, it should be in factor of 2 times of what we are taking here on NMOS structure for PMOS. Here that is beta factor to equalize rise time and fall time. So let's not go deep into CMOS, right? Now question is, now I want to fabricate, I want to design a mux, right? I want to design a mux. How many transistors are required to design a mux? So I will say 2:1 mux. Simple. First of all, how many inputs a 2:1 mux has? How many? Two? Two inputs, one output. Is it correct? Three inputs, right? So 2:1 mux have three inputs, not two inputs, right? So if we design 2:1 mux, we have three inputs: data, right, and select line, and we have one output. Now how we are going to design this? How we are going to get the count of transistor? Yes, enable. If it is a, if you want to add control signal, if you want to control the mux, then you can add one more input. That is correct. Enable. That is not always true. If you want to control mux structure, then you can add enable pin. So we have both the libraries, without enable and with enable also. It depends which library we are using. So we'll go by just simple basics. Let's say there is no enable pin. Okay. Now tell me, enable is nothing but control signal. It is a non-functional pin. Is it a functional pin? It is just controlling the design. So select line and I0, I1 is your functional pin. What is the Boolean expression? What is the Boolean expression? S bar I0 plus S I1. This is your Boolean expression. Now can you tell me how many transistors will be used if you are using CMOS design?
6.
Let's make it simple, right? How many logic gates are required to design 2:1 mux? 3. What are those? How many AND gates? 2 AND gates and 1 OR gate. That's all? Inverter. So it is 4, right? So 1 inverter. That's correct. So 2 AND gates. Why? You can see here 2 AND gates, right? And 1 OR gate, right? And how many inverter? Right? So how many inverter? 1 inverter. So this is S, I0, I1 and Y. So this is logic design. This is called as logic design. This is called as block design, right? Block level representation. This is logic level representation. Now can you convert this design into transistor level representation? So from that you can calculate how many number of transistors are required. Now can you easily calculate, right? Can you tell me how many transistors? 2 for inverter, right? For AND how many? 6. For OR 6 or 4? 6 only, because it is not complemented. For NOR it will be 4. What I said in first, CMOS is a complementing, it gives complementing effect. All the designs of CMOS gives inversion effect, right? So how many total? Around
6.
20. No, total number of transistors, that is correct. So total number of transistor will be required
1.
as 20 transistors, right? Of course, this can be simplified also, and you can reduce number of transistor at CMOS level design. That is not true that you need to use so many number of transistors. How to calculate and OR gates? Just now I have explained that all the CMOS gives inversion effect, right? So let's say this is your NAND. Okay, now you want to get rid of inversion effect of this design. What you will do, just add one more inverter in front of NAND. It will make it, and right, same for OR also, right? Same for OR also we have to do. That is how we are getting 6 transistors for OR and clear. Now this is only for 2 cross 1 mux, right? How many transistors? Let's say 20 transistor. What about 4 cross 1 mux? Approximately, right? Just going by basics. We are not simplifying or not reducing number of transistor. Just going by basics. What will be the count of transistors? What will the count? 4 is to 1 mux. Simple. We are going step by step. How many 2 cross 1 mux are required for 4 cross 1 mux? 2 or 3 or 4, right? It should be 3. How many select lines are there? 2 select lines. So we say LSB and MSB. So on MSB, which select line will be placed? Most significant bit, right? S0 is most significant or S1 is more significant?
0, sir.
Remember, you need to recall digital basics also. So this is not only about CMOS basics. You need to be good in digital basics also, right? Okay, so how many transistors? How many number of transistors? So 3 2 cross 1 mux are required. See, we are going just by cell based placement. I will place how many 2x1 mux? 3. These are 2x1 mux. I0, I1, I2, I3. Right? This is Y. Select line. Most significant bit will be on the output side. Right? So it is what? 4x1 mux. Understood? What about 8x1 mux? How many 2x1 mux are required? So we don't need 2x1 mux. We already have 4x1 mux. We can use directly 4x1 mux. How many 4x1 mux are required? 2 or 3? 3, right? So you can check. So you can think number of transistors are growing. So here it will become what? 3 times 60 transistors. Okay. Next, if we talk about 8x1, again what will happen? Transistor count will be increasing in multiplicative factor. What is the point we are trying to understand? We are not learning digital or CMOS here. We are learning design perspective, right? So think about it. So what is happening? It is getting it is increasing in multiplicative factor. This is just simple mux. What about ALU design, where you have to use multiple number of mux, multiple number of full adders, and a different number of sequential cells also? Think about it. What will be the transistor count? It will be in multiplicative factor. It will increase like anything. Now a processor design have billions of transistors, right? When we say a transistor, and when we say, so we have a 180 nanometer scale. What does this mean? So it is a channel length of a transistor device, right? Now, how small is this? Can we see this from naked eye? Is it visible from naked eye? Can you see it? So we have seen what is going to get designed. Now we are discussing what is the size here. So it is not visible from our naked eye. Then how we are going to see it? Can you just imagine what is this size? Compare. What is the size of coronavirus? Can you see coronavirus? Have you seen? It will be somewhere near sofa or kitchen, you might see, right? Is it visible? Not visible, right? Why? Because of its size. What is the size of coronavirus? You can check if you want, in your phones or something. So there are multiple variants. It's not a fixed size. So there will be range of size. What is the size? You can check. You can use your phone. There is no restriction. You don't have phone? 62? 140, 60 to 140 nanometer, right? So today in industry, we are working in 2 nanometer currently. And we already have chips in Samsung, in other phones. They are using 3 nanometer chip. Already it is in market. 2 nanometer chips are not everywhere. But yes, for some application, 2 nanometer chips are also there. We are also working less than 2 nanometer chips also. Now can you imagine how small your design is compared to coronavirus? How much, by what times it is small? So it is very, very small, very less. Even microscopes will fail to see this design. Why? Because it is in nanoscale. Below 1 nanometer, it will go into subatomic particle. You cannot even, any microscope can also not see those subatomic particles. So it's very difficult. It's very, very small. And there are a lot of challenges and lot of complication while doing physical implementation of these kind of designs. Very difficult. So all those challenges we will be discussing here only in this course. Okay, so it is very small. Now where it is getting fabricated, now if it is very small, right, how we are going to design it, whether we are going to use pen and paper, right, whether we are going to use something called as some tools or something, right, how we are going to design it, how this is ultimately what. So if you want to design a mux, how you are going to design the circuit, how it is possible. So for that, we need some specific tool. Those tools are called as, which is used for electronics, it is called as automation tool, which is called as EDA tool, electronic design automation tool. Don't confuse with CAD tools, right? It is similar to CAD tools, but not CAD tools. Why? What is the reason? In CAD tools, all the CAD tools, whether it is AutoCAD, whether it is Eagle CAD, which is used for PCB design, or whether any other CAD tools, right, which is used for infrastructure designing, building designing, interior designing, all those are different from EDA tools. Of course, this is also looks like CAD tool only, but what is the major difference? EDA tools honors electrical parameters. EDA tools honors your digital and CMOS concept. So technical concepts, it respects your technical concept and technical subject. That is why it is called as electronic design tool, right? Design automation. It is not called as computer aided design. That is why it is called as electronic design automation. Can you name any tool names if you know, if you have worked? Cadence. Cadence is a company. So Cadence develops lot of tools, right? Virtuoso. That is correct. Anything else? Synopsys. Synopsys is also company, right? It also develops multiple number of tools. ICC, right? Cadence, we have Innovus. Tempus. Tempus is a cadence.
Reward, sir.
Mm-hmm. Prime time. Vivado. Okay. Vivado is something different, right? It is not used for physical implementation. It is also a EDA tool only. That is correct. Vivado is used for RTL designing. That is correct. So it is not a physical implementation tool. It is a front end tool. It is not for us. Mentor Graphics is a company. Again, now they have been absorbed by different company. Questa Sim also, right? Questa Sim is used for system Verilog. Mentor Graphics also develops lot of tools like Calibre. Right? Calibre is used for physical verification, which will be our part only. Questa Sim is used for system Verilog. So this is not our tool. We are not going to use these tools. Front end tools. Yes, Mentor Graphics from ANSYS, yes, they have developed Red Hawk tool. So it is used for what? Power analysis, EMIR analysis. So we'll see all those. So there are many electronic design automation tools. Don't think that there is only one tool which can cover everything, right? By the course of time, you will understand everything, like which tool and how it can be used. Okay. Now, problem here is whether these EDA tools are open source. No, these tools are not open source. So they have specific licenses which needs to be purchased. So some licenses are very costly, like Redoc tools are very, very costly. Licenses no one can afford easily. Not all companies also have Red Hawk tools. It is that much costly. So Innovus is costlier. Innovus and these ICC2 is also costlier. But we have licenses for both the tools here in our institute so that you can get used to it while practicing on your design. Okay. So this is about tools. Now we have discussed about design, transistor and its integration, right? Before VLSI, we talk about LSI, large scale integration and small scale integration. What is happening? Why the technology node is shrinking? So we say that there is law called as Moore's law, right? So for every 2 year, 1.5 by 1.5 times, technology node will shrink, but that does not apply in deep submicron region. That stopped when we achieved 45 nanometer or 19 near to 45 to 90 nanometer. Before, after that, it's not following. We are not following Moore's law anymore. It does not apply for lower techs because now CMOS is also not realizable at that level. So we have different devices now. We are not following CMOS in very lower techs like 2 nanometers. We are following FinFETs, right? Have you heard FinFETs? Yes, those are called as FinFETs. Now, in deep nanosheets, we are also not following FinFETs. We are following GAFETs, right? What are GAFETs? So don't worry, we will go with CMOS design only. So majorly still in industry, 80 to 85% of designs are based on CMOS only. 2 nanometer chips, 3 nanometer chips are only used for commercial products like mobile phones or some high-end performance devices. But it cannot be used for medical applications or military applications. Why? Because there is a criteria for robustness also. Because 2 nanometer and 3 nanometer is so small that it is very uh, sensitive to lot of different factors. Even your phones, you use your phone, how many years you can use your phone? After 5 years, whether your phone operates in same speed, same performance level, or it keeps lagging, or if it keeps getting slower and slower, right? And screen brightness will also be changing, right? It will not be same. You open an app, it will open after some seconds, it will get delayed. Why this is happening? By the course of time, your chips will also degrade due to a number of reasons. That is called as robustness. So robustness is always less in lower technology node. Okay, that is just application point of view I am telling you. So when we say we want to design something, right? So where we are designing? So wafer, we call it as wafer. What is wafer? How fabrication is done? We take sand, right? Why we take sand? Silicon. What is the source of silicon? Sand, which is, why only silicon? Why not germanium? Germanium is also semiconductor, right? Why? Germanium is better or silicon is better? Which one is better? Sure. Why silicon is better? What is the threshold voltage for silicon? And what is the threshold voltage for germanium? Zero point 0.3, right? Then germanium is better, right? It will conduct faster. It does not need to wait till 0.7 threshold is reached. It will conduct faster than silicon or not. It is more faster compared to silicon, right? Germanium is more. But whether germanium is abundant in nature, whether it is availability is cheaper than silicon, no. So yes, germanium is also used to design silicons, CMOS design, but not for all application. Yes, Jagdish, thermal stability and cost is major factor. And yes, not only cost, there are other factors also which gets affected. Now silicon has a source which is extracted from sand, and sand is abundant in nature. We don't have shortage, lot of sand. So what happens? From this sand, silicon is extracted and it is converted into a cylindrical shape which is called as ingot. What it is called as? In ingot. Okay. Then what happens? that this cylindrical shape of silicon, pure silicon, right? This is pure silicon ingot. This is sliced into multiple disc like shape, right? Like you take a potato, how wafers are made, how chips are made, potato chips. You have eaten or not? You have eaten many times, of course. So you take one potato and you slice it into what? Chips. That is why you call it as chips, or you some people call it as wafers also, potato wafers, right? So like that only for ingot, we are slicing it into multiple disc like shape. So you will get what? Something like this, top view, right? So it is a wafer. Now this is a silicon wafer, complete disc. What is this? It is a pure silicon, right? Without any impurities. What are impurities which is used? What are impurities which we add in silicon? Trivalent atoms or pentavalent atoms. So you need to be good in semiconductor physics also. So I'm not teaching all this subject. I'm telling you what is important to start with physical design. Okay. For what we have seen first, you should be good in digital. You should be good in CMOS. Now, this concept should also be clear. For that, you need to good in semiconductor physics. So impurities like trivalent atoms and pentavalent atoms. What are trivalent atoms? Boron? Forgot? Third year or what second year you might have studied, right? Third semester, semiconductor physics. You might have drawn silicon crystal and done some calculation. And what are pentavalent atoms? So trivalent is deficit of valence electron or free electron, or pentavalent is having extra electron, means it has additional electron which act as a free electron. Right, pentavalent has, right Pallavi, pentavalent has 3 valence electron, means additional electron is there in valence, or the what we say. Silicon has how many these bands? How many shells? 3 shells. Ground state we have 2 electrons. Those are extremely stable, right? Extremely stable. We need lot of high amount of energy to break that shell. Then comes what? Second shell. How many electrons are there on second shell? How many total electrons in silicon? 1, 2, 3, 4, 5, 6, 7, 8. Okay. Now how many electrons will be there in next cell? How many? 4, right? So this is what? Stable silicon. How many total? Total number 14, right? This is what? Pure silicon. Stable silicon without any impurities, right? Now how we need to, like, how we need to make it conduct? It is already in stable state. For that, you need to add any impurity. So we need to make it electron deficient or having additional electron, right? Then only you can start make it more conductive. Now conductivity, when we talk about what is conductivity, it depends on 2 factors. What is that? Conduction is due to what? Electrons, and is it correct to say conductivity is due to holes, or it is always electron? Confused?
Holes
So you,
and electrons both.
It is always due to electrons. You might have studied, okay, that majority charge carriers are holes. So now holes are responsible in conduction. That is absolutely wrong statement. Conduction is always due to electron movement. Holes are nothing but a void. It is no, it is a non-object. So you have multiple number of holes. Conduction is only due to electron density and electron drift, right? Electron velocity we say. So electron density and drift. So how it is moving and what is the density? That is giving us conduction. It is never whole. It is just a way of saying. So if you have more number of deficiency, right? So electron movement will be in a different way. If you have less number of holes and more number of free electrons, what will happen? See, the majority charge carriers are free electrons, right? And the conduction will be more dominant because of electron. It is a way of saying, but conduction is always due to electron. Current is due to movement of electron, right? It is never whole. Don't say that statement. So this is basic level, very device physics level, or we say semiconductor physics level. So from here we are adding impurities and we are getting N-type material or P-type material. We are getting N-type material by adding impurity of pentavalent atoms. We are getting P-type by adding trivalent. That is how you are getting what? P mass and N mass. How you will get P mass? By diffusing trivalent atom impurities or pentavalent atom impurities. Hmm?
Pentavalent.
You need to diffuse, you need to get P-type material here and here. How you will get P-type material? By diffusing trivalent atoms, right? So you'll get P-type. If you want to get N mass, so which impurity will be diffused during fabrication? Pentavalent atoms will be diffused. So you will get N, this is N plus means what? Plus means it is doped by impurities, added impurities. So to get N type material, if sometimes we say highly doped, you might have read in some books, right? Sometimes it will be written doped, sometimes it will be written very highly doped. So we'll say N plus plus, right? Or triple plus means very highly doped. Understood? Based upon how number of impurities we are adding, your design or the device physics will change, material will change, material behavior will change. This is about material physics. How material level will also affect your design, that is also important to learn. Not only design level, we have discussed transistor level, design level, so you should be also knowing about material physics also. Now it will be sliced into wafer. Now what next will happen? Next, after getting wafer, so this is our silicon chip, or sorry, wafer. And then how we are going to fabricate a small chip in this wafer? How it will be fabricated? Like it is a complete design, right? There will be marks, there will be lot of MOSFETs, those will have interconnects, there will be lot of metal layers also. How it is fabricating in silicon? So for that you need to understand, if you have worked in PCB, right? PCB design, how many of you have worked PCB design? Have you designed any PCB? No one has designed in your maybe some lab or electronics. You have worked on breadboard you have worked. Now, whatever you have validated and verified in breadboard, right, it is functional. Then you will be converting into PCB or not, and then you will mount all the components. Have you done that? Not done. Huh?
There's a dot board reference.
Oh, already ready-made. So I am telling breadboard.
Also, like dot boards, we can just like.
Oh, just mount and tap and it is ready to use. No, basically, so how that is made? Okay, that is simple thing. But if you get a copper clad, we say a copper clad, right? Copper clad means it is full of copper. Copper material will be there on top of one plastic, right? Now what happens? Complete copper is there. How you are going to, have you seen PCB, that green color one? On back side you will be seeing some kind of network, right? Something like this. Have you that, at least that you have seen, right? How it is getting that interconnect, how we are getting that connection. So we'll take one copper clad, so it is full of copper material. Then what they do, then what we do, on this copper clad we will draw something with marker or permanent marker, or now we have eagle. There is one software called as eagle software which is used to design PCB. So you can print that network and you can paste here, and that print can be imprinted here. So I've taken that. Let's say your network is something like this. Okay, so this next they will be doing drilling and all, not right now. Okay, let's say the network is something like this. So it is printed on what? Copper clad. Let's say you take permanent marker and you have drawn this, right? Why we are drawing this? Why we are printing that the network on PCB? That is acting like a photoresist, right? That is acting like a, this is nothing but photoresist, right? That is nothing but photoresist. Now what you are going to do, you will create one solution, ferrichloride solution, right? You will mix in water. Now if you take a ferrichloride solution in one bowl, right? Yes, Gautam, films. So you take a ferrichloride solution on in bowl, right? And in presence of sunlight, this is very simple and cheapest way to design a PCB. You can also do at home. It's not very costly thing. That is why I'm not telling machine-based PCB designing, which is very complicated. So this you can do at home also. In presence of sunlight, you dip this whatever after printing, dip this into ferrichloride solution and keep moving it under presence of full bright sun. What will happen? All the copper, wherever photoresist is not there, it will get washed off. That process is called as etching, right? That process is called as etching. So now all the copper will be washed off in that ferrichloride solution. Only that photoresist part will be remaining. Now, why this is happening? So this is nothing but catalyst. The ferrichloride solution is nothing but catalyst. In presence of UV light, right? So we know that sun rays have UV radiations. In presence of ultraviolet rays, this copper gets reacted with ferrichloride solution and it gets washed off. So now you erase all this marker and you will get this copper network on that PCB. Then what they do? They will drill all these terminals. They'll do all this drilling, right, with some machine or something. And then they will start mounting component on the opposite side where copper is not present. Is doping. So I'm telling simple basic PCB design. Then they will mount it and then they will make the soldering and they will check continuity check, and with millimeter they will do continuity check, and then your PCB is ready to test. Functional or not, it's the later stage, but it should be functional. Same, but not so simple here in nanoscale fabrication. We are following, we are inspired by that same thing what we have discussed now. So here, to fabricate very complex design, billions of transistors in this small area, what we try to do, we need a source of what? UV light, right? First source is UV light, and that will be passed through some sort of lens, and then it will be passed through. So now the question is, we need to print the design. Printing means what? Printing is not in 2D. All metal layers are in different level. Substrate and diffusion layer is not in same plane, right? We know that it is 3D. It is in different plane. How we are going to fabricate them? Layer by layer. And how it is possible? Through mask. Right? So mask will have each layer definition here. Something like this. This is for it. So there will be multiple number of masks for each layer. So each mask will be used one by one to fabricate layer by layer from bottom to top, from substrate to top metal layer. That is how it will be getting fabricated. So it will keep on imprinting on this particular area. What is mask? What is mask? What do you understand? So in Deepavali, right? You might have used or seen your mother or sister using stencil, right? To design rangoli. In Deepavali, we used to get in market different designs. So what your creativity will do? You will purchase 3 different rangoli stencils or mask, right? Why? You want to make very unique design out of it. If you use only one mask, one stencil, you will get one flower, something like this, simple design. Okay, but now you thought to make it very unique. Now you have purchased one more mask which is having different sort of design, let's say a star, something like this. Now you have taken 2 masks. First you will be placing this mask and designing that flower, and on top you will take second mask and you will keep on top of it, and you will get what? Stars also. Now once that is completed, you will see one good unique design that cannot be achieved by one mask. So multiple masks will be used to print each and every layer design. Is it clear? So this is a fabrication step in brief. Okay. So we'll come back to the, so I'll discuss some course structure also. This was briefing on what are there in VLSI, what are the things we have in VLSI. So I will also discuss PD flow. Right? Before that, I'll brief you about course structure. Yes, lithography process. So all these steps will be explained in detail when we start with the course. Okay. So this course, physical design course, will be for 6 months. Out of that, as you know that you might have studied digital a long back, third semester, right? You might have forgot many concepts. You need brush up, you need revision. So for which topic? Digital, CMOS, semiconductor physics, and some other text editor or those simple basics things, right? Those will be taught in PD basics for 2.5 months, so that you get confidence in basics, and then you will be very comfortable in advanced topic of physical design, right? Next, so in the PD basics, the topics which we are going to cover here, that is digital, and GVM is nothing but a text editor. It's like a notepad, but with some extra features, right? Command based features. With command, you can edit and replace lot of words in that text editor. It is very helpful. So it is not a PD thing, but it is helpful in working in PD. Then we know that most of the industry does not work in Windows. They work in Linux environment. So you should be familiar with Linux or Unix environment also. What are the commands which are used in Unix and Linux environment, that will be taught. So Linux and Unix are basically open source, but in industry they use licensed version. Okay. Then you also need to have some level of programming knowledge also to make your work faster. So here we are going to learn Tickle script or tool command language. It is called as TCL, tool command language. It is a scripting language that will be helpful while designing, uh, working in physical design. Okay, CMOS basics will be covered, and then we'll also brief you on small briefing on physical design also for 3 to 4 days. Okay, class timings on weekdays from Monday to Saturday will be for 3 hours. It is based upon availability and what is your demand and what is your request. Like if you say we want, the batch wants a morning session will be provided to you. If batch wants evening session, sorry, afternoon session, so we will provide afternoon session post lunch. It depends on batch request and requirement, on based upon your comfortable. Okay, that is for Monday to Saturday. Sunday will be holiday for you. Okay, and now most of you are from regular batch, I guess. So for those people who are working, office goers, they don't have time in weekdays. For them, we have weekend slots scheduled. For them, they need to attend on Saturday, Sunday. Okay, that is also for 3 hours. Each and every session will be live recorded. Okay, and pre-recorded videos are also there, but it is better to follow live recording because live recording is always updated teaching according to in line with industry. Pre-recorded maybe 2 years back, 3 years back, we don't know, it can be outdated also. Live recording or current recording will always have some updated knowledge. I will also keep adding in every batch, I'll be adding new things. So that is why you should also always follow live recording or current session. Okay, each and every session will be recorded. You don't have to worry about it. It will be uploaded on the same day in your portal, student portal. So from there you can access those recorded videos. Suppose in class you didn't understood, or some trainer is going very fast, or trainer taught lot of things in 3 hours and you didn't able to catch up few things, so you can rewatch it to understand that concept. Still, if you didn't understood after rewatching, you can again come back tomorrow and ask me how it is done, and you can explain me again, I'll explain that. So that is also there. Okay, any question? Now, next 4 months, after 2.5 months, next 4 months will be for PD Advance. So these 4 months are very, very important because this is your main subject, this is your main skill, which will help you to land up in job, right? Of course, basics are also equally important, right? As a fresher, they will give more stress on basics also, right? So here you will be assigned with one project. So project we have both in 14 nanometer and 28 nanometer. We are now working in I think 5 or 7 nanometer also. So currently we have all the toolkits and the libraries for 14 nanometer and 28 nanometer also. So the project will be assigned to you on 14 nanometer scale and 28 nanometer. So what you have to do, you don't have to like do it by your own. So we will be assisting you, we'll be guiding you. That will be called as lab sessions. But you cannot do labs without any conceptual knowledge, without any theoretical knowledge. For that only we also have theory classes also, theory sessions also. So on Saturday and Sunday, we will have theory sessions, okay, or PD advanced theory session. On weekdays, we will have lab session. From Monday to Thursday, you will have lab session. Friday will be holiday. and Saturday, Sunday for all the batches, whether it is weekend batch or non-weekend batch, weekdays batch. For all batches, theory session will be common. Lab session won't be common for all the batches. For weekdays and regular batch, you can attend weekdays Monday to Thursday, and for office goers or those who cannot attend on weekdays, they can attend lab session on weekends. Okay, any question here about timing? So both the modes are also available, online as well as offline modes are also available, but the preferable mode is always offline mode, right? Because offline mode you will be very focused and very concentrated. In online mode you might get distracted by something else, you might get distracted by your phone call. Offline mode is always better. So if you are near to institute or you can come to institute, always choose coming to institute. Okay. So once this course is completed, you have completed successfully, then we will also assist you in getting you placed in some good company, right? So we'll be providing you with different opportunities. But before those opportunities come to you should make sure that you follow the course structure as well as the preparation structure also. Only learning is not important. With learning, you need to improve your different skills like communication skill or English speaking skill or answering the question, technical question. That skill also needs to be improved. That all skills will be covered in interview preparations. So those preparation sessions will also given inclusive to soft skill, means you will also have communication based class also, like how you should introduce yourself, what should be your resume, what you should put in resume, what should be the format of your resume. All things will be explained in these sessions. So also once course is completed, you should make sure that you attend and give all the test. Do not miss any test. That is very important. Assignments will be given after each stage. Suppose digital completed, you will be given some question of assignments, many question, not some. Okay, then you will give CMOS. You will learn CMOS. Then we'll give some question, lab as well, something like that. Okay, then we will have PD Advance. In PD Advance, we have prepared assignments stage wise. So as you know, the first stage is floor plan, then placement, then CTS. After each stage, we will take test as well as assignment. Why we are doing this? So that you be very attentive, serious, and your preparation should be uniform. It should be not your non-uniform. Though you should not wait to complete course and then I will give test, then I will write all the Everest like assignments. Then you cannot complete. You will lose your motivation to complete assignment. Then there will be 300 questions. You cannot solve 300 questions in one day. Suddenly management will come and tell you that there is one good opportunity, whether you are ready or not. So what will be your answer? I'm still writing assignments. That should not be your answer. So after every stage, you should complete your assignment. So we will be assisting on those assignments also. So you don't have to worry. Regular test. Why we are taking regular test here? Because it will help you to understand where we stand, how much we understood, why I am not able to answer this question. It will help you to find out your loopholes, and then you can fill those gaps, right? So all this continuous process will happen during the course structure to keep you in track. So placement process is very simple. First complete your course, attend all the classes, have a good attendance, do all the lab assignment, clear all internal tests and mock interviews. Oh, mock interviews also will be given once course is near to the end, right? So that you get habituated of that interview environment. Why? Because interview environment is what? Suppose I want to ask what is your name? Can you tell? Hmm. Your name? Manikanta. Your name? Your name? Can you tell me about yourself? See, this happens, right? Why interview session environment is what? Pressure environment. So if you get habituated to mock interviews, that pressure environment, how to tackle, how to feel that pressure, right? You will be very comfortable in real interview. That is the reason mock interview is provided. So you should not miss any mock interview. It is to improve your communication skill only. Okay. So we'll take a break and then I will discuss PD flow and then we'll conclude and we'll take any other questions if okay. We'll take a break of 15 minutes, 15 to 20 minutes and we'll resume at 11:20. Yes, we'll resume from here. So we have discussed, we have briefed, right? We have seen briefing on what VLSI, and then we have seen course structure, and then we have also seen placement process. So now we'll discuss VLSI design flow. We have already discussed chip fabrication. What is the difference between fabrication and design, right? So this is just nothing but summary of difference between chip fabrication and chip design. So what is the difference here? Where the most of the important work is done, that is called as chip design. So what it involves in fabrication? So manufacturing semiconductor chips in fabrication plant. Can you name any chip fabrication plant? TSMC, Global Foundries. TSMC is in Taiwan. Global Foundries is in US, right? CIMIC is in China, right? And we have Intel and Samsung. These also have their own foundries. 85% of market share is held by TSMC. Okay, they produce, they manufacture most worldwide. That is 85%. Is a big number, right? Next comes, so what happens in design? So we we take one problem statement and try to design that circuit. What is that problem statement? It can be anything. It can be your AC, automatic AC inverter. It can be your smart washing machine. Like by just mobile phone, you can switch off you're in office, you want to switch off your washing machine. You can switch off from mobile phone itself. That is because of hardware chip which is present in the washing machine. Same for TV. Nowadays we are having smart TVs. That's TV. What is the advantage of smart TV? Now you can connect to the internet. You can watch OTT or something else, right? Which is very easy to access and easy to operate. It can do lot of stuff. You can connect into keyboard and you can use it as computer. You connect with CPU. So all these functionalities are there in TV also. Then you have portable devices. What are those? Earbuds, right? Your smart watches. All those have what? Chips, right? Those are VLSI chips. Those are for portable devices, low power devices. Now depends on problem statement. We can design as per the need. Okay. So foundries, so these are designed in the design based company, which only works on the design level, circuit level, or challenge the problem statement level, right? But whether it is a physical design, physical visibility is there? No, it is all on your tool, EDA tool. You're designing in EDA tool. It is still not realized into physical silicon. Where it will happen? It will happen in foundry, right? That is called as fabrication labs. Okay. So the fabless company means design based company. Are some examples are Qualcomm, AMD, Nvidia, anything else? Samsung is also both. Actually, it also have fab as well as design, but we cannot say pure fabless. I'm talking about fabless. MediaTek. MediaTek is a fabless company, right? Any other company name you can recall? Hmm? So you should be knowing company names also if you are coming. Micron, good. Silicon Labs. All these are design-based company or fabless-based company. So foundry-based company. Intel and Samsung are those company which is also designing, also fabricating. They have their own fabrication labs. Okay, but they do not produce or manufacture in large scale like TSMC. So what are the tools used in design? We already discussed, those are called as EDA tools. What are those tools?
Ella,
CIS,
Ella,
ICC2, right?
yeah.
Fusion compiler.
Pati karmi
And
tha.
in fabrication labs, we use Caliber, T-Center, PVS, manufacturing-based tools, which is required to
हाँ,
manufacture design.
बर्तन धोबी.
Process. What is the process here in fabrication? Photolithography process, etching process, doping process, deposition, right? Oxidation. All these process comes under fabrication steps. Out of these, some I have given you brief idea on how fabrication works. What is etching, right? What is oxidation? What is doping? Why we are adding that impurity during fabrication? To get some particular specific material, right? That is called as n diffused or p diffused. That is why it is called as diffusion layer. Next, so in design flow, we have certain level of flow. It's like in fabrication, we have steps. First, we'll take one silicon and then we will add photoresist, and layer by layer or mask by mask, we will be etching, right? From bottom to top. That is what fabrication starts. In design flow, we have separate flow. It starts from RTL, synthesis, physical design, and finally verifying the design, whether it is correct or wrong with respect to logical, functional, and physical aspect. Right? I'll explain you that on the design. What is the final output of fabrication? It is that silicon chip. What is the size of silicon chip? Approximately size of your fingernail or half of your finger. Roughly speaking. I cannot give you exact number because design to design it might change. Yes, am I audible to all, or is there any sound issue?
Someone has turned on their mic, sir. That's the issue.
Yes, yes, yeah, is audible, right? Okay. So, okay, but then why it's not audible to us? Okay. So I was telling, so what is the output of fabrication here? Okay. What is the output of fabrication? Is what is the output of fabrication? It is the silicon chip, right? Whether that silicon chip will be as it is used in the application,
Has to undergo verification.
verification is done. Let's say there is no issue, your chip is fine, whether we can directly use in application. So you go to market, right? You purchase something. So purchase some sweets. You will take that sweets in hand and come back home. You need to pack it, right? You need to do some sort of packaging. Why we are doing packaging? To protect it from flies or some dust, right? Same way, this is very sensitive chip in nanoscale. You cannot just keep it somewhere in your motherboard or the PCB layout. You need to package it for protection. Yes, we supposed to test and pack it. That is correct. So of course, let's say testing is fine, everything is gone good. Then you need to pack it. Why we need to pack it? To avoid interference from the external world, right? It can be thermal, it can be electromagnetic wave, it can be anything. It can be electrical interference also, electric field interference also. To protect from other external thing, we will do packaging. Right? Final output in design is GDS2. What is GDS2? What is GDS2? It is a graphic based design information. Okay. It is a graphic data system information. What kind of information is there? It is only having information about physical shapes of your design. When we talk about physical shape, what does this mean? Suppose I'll give you one simple example. Okay, so we have CMOS, right? This is PMOS, first one, and this one is second one. Both the inputs are common, and this is supply. This is connected to ground, and this is output. Now this is PMOS and NMOS. How it will behave like? It will behave like CMOS, or you can say inverter, or you can say it is a NOT, logical NOT. All are same. Y is nothing but A bar if input is A. So this is what simple CMOS. Whether it is a physical design, can we call it as a physical design, or whether how it will look like in silicon, on silicon, how it will look on silicon. It is a symbolic representation, right? It is not the physical object. See, when we talk about, so if you are a fashion designer, so you will be designing on paper a very good dress, shirt, pant, or some gown or something, right? Whether it is an actual design, it is just a pen and paper design for a symbolic representation. It is not the actual size, but of course you will be following the scale, right? Then you need to realize into the, then you'll stitch and you'll do fabrication of clothes, and then you will get that dress. That is the physical output, right? So designing is basically all on tool. It is not physical. So how to get it? How it looks like? So this PMOS, right? You will have, let's say, this is your complete pure silicon wafer, right? Or a part of pure silicon. Here you will create, you will do etching, right? Etching of what? Let's say N-well, right? You will do N-well etching. This is N-well layer. This is, so pure silicon is by default P type material, generic material, pure silicon. So this is what N-well. This is P type and this is N-well. Now in N-well, I will diffuse P type material. I will diffuse P type material. Okay. So this is what PMOS. This is what PMOS. Similarly, I will diffuse N-type material here. Okay, and this becomes what? NMOS. And then you need to make proper connection, right? This is drain, sorry, this is source, drain, and source. So source side of PMOS is always connected to the supply. Drain side of PMOS is connected to the drain side of NMOS, and source side of NMOS is connected to the ground. Clear? So this is your NMOS, right? So PMOS and NMOS. Then you have to do connection. Okay, something like this. So you have to make proper connections. So this is a cross section of physical CMOS. So how it will look like in a semiconductor base or substrate. You take a wafer or take a part of chip, and if device is already fabricated, you cut it into one half. Right? I will show it. Image, right? This is your substrate, P substrate. So here we will etch with NVEL, and we are placing P plus P diffusion layer and P diffusion here. Some sort of this circuit. It is not an inverter. Don't get confused. You can see what is this. So it is. You can see there are multiple transistors which is connected in series. Okay, you can see that it is N diffused and then P diffused. So it is some kind of circuit it is showing. Try to understand the step. We are not going through the design. Okay, so it is first substrate and then NVEL layer which is etched, and then comes your the diffused layer. So N-type material, P-type material, right? Then again N-type and N-type. So this is N-type and N-type means what? This is NMOS here, right? And then you have P-type material, okay? And then it is connected. This is some sort of metal layer which is used for interconnect here. So this, you can see that step is going from bottom to top layer. Understood? So what I was trying to say, that each design will be converted. So that was cross section. Whatever you have seen here, it is a cross section. So if you observe from the top, how it will look like, how that uh, shape will look like or layout will look like. So I will draw that also. So first comes what? PMOS. So PMOS requires NVEL and you require NMOS. For NMOS, you require diffusion layer. Which diffusion layer? N diffusion layer. Right? This is NVEL. Inside NVEL, you will have P diffusion layer. So this, what I am drawing here, I am drawing top view. N well. This is what? P diffusion layer, correct? This is N diffusion layer, not P diffusion layer. So concentrate. This is not P diffusion layer. This is N diffusion layer. And this is P diffusion layer, right? And then comes poly. Right? Then on top of that, poly. So I'm drawing layer by layer. So first substrate. So substrate is that also I'll draw. So let's say this is substrate. This is substrate. Outer boundary is a substrate boundary. We are seeing from the top. We are not seeing the cross section of device. Okay. On top of it, in this particular area, we have etched N well. We have seen cross section, right? N well. And then P diffuse, we're diffusing with what? P type material, then N type material. And on top of that, metal. So this is input is common to both, and then you have to do metal interconnect. Okay. Something good. So I'll show you that. So it is called as CMOS layout. That view is called as CMOS layout. So this is what? This is a top view of design, CMOS inverter design. What is this? N diffusion or P diffusion? This is N diffusion layer. This is P diffusion layer, right? What are this VDD and ground? Big blue, sorry, not this one is not N diffusion. So it is vertically placed. N diffusion is vertically placed. This blue color one is metal. Okay, this green color you are seeing, right? Internal light green color, which is a diffusion layer. This one you are seeing, right? This is a N diffusion layer. Okay, don't get confused. It is just orientation is different. And this is supply. So what we have seen, supply must connect to the PMOS source. Drain of PMOS must be common to the NMOS drain, right? That we have seen in symbolic representation. Remember, you are able to relate with that symbolic representation. And source of NMOS is connect to ground. Output is taken from the common drain point. See, the output is here. This is the common drain. So it is an inverter pair, not single inverter. That is why you can see we have two layouts, right, connected together. The output of this inverter is connected to the input of next inverter. You can see the drain is connected for this inverter, which is connected to the input of next inverter, right? Then output you can see it is going here. So this is this output, and this is the input of first inverter. So this is called as physical view of layout. So this is how it will look once your fabrication is done. If you look it from top view, all the layers and cross section, as we see, you will see all the layers. That is called as cross sectional. Okay, clear how it looks like symbolic representation, how it looks here in physical representation. Clear, right? This thing. So this will again you will be taught in CMOS. Don't worry about this. These are the layers which is used to design, right? These are all manufacturing based layers, physical layers. These are not symbolic. From here onwards, we are not talking about symbolic meaning. It is all physical representation here, which will be used in fabrication. So don't get confused with symbolic and the physical representation. Okay. So how we are going to give data to the fabrication when your design is completed? Your design is completed. You are not going to give symbolic representation. What you are going to give to the fabrication lab, to the foundry, GDS2 file. And what it contains? Layout information, physical view information, right? We are no more giving any logical connection. There is no logical connection now. All are physical information. What is the shape size? What is the diffusion width? What is that length? Everything is physical aspect on physical parameter, and that all information is present in which file? GDS2 file, and that will be given to foundry. That is the final output, and then we call it as tape out. What is tape out? Tape out once design flow is completed. So taping out is nothing but you have seen in a suspense thriller movie, right? Some sort of detective movie. So they take some scanner will be there to open one locker or something. They'll take sellotape, transparent sellotape, and they'll take fingerprint, right? Imprint, and then they will use it on that scanner, and then it will get scanned and door will open. So what is that? Taping out the fingerprint. Understood? Similar way, we are taping out the design, and that taping out file is called as GDS2. And that impression, that design, that taped out design in GDS2 format is given to which one? Who? Foundry, fabrication lab. So first, so this is called as ASIC design flow. Okay. So there are different types of design flow. One is FPGA based design. One is semi-custom based design. All and full custom based design. All these are part of what? ASIC designs. What is ASIC design? Application specific integrated circuit. Now simple thing, right? Application specific means what is our problem statement? What is our application? So we are going to design purely based on application. Suppose I want to design a portable earbuds chip for a portable earbuds. So my application is fixed. It should have audio module. It should have a connectivity module like Bluetooth, right? Some sort of transmission and receiving entity should be there in that design. Suppose you are designing a wearable smartwatch. It should have display feature, right? It should process data. It should take calls. That feature should be there. If suppose you are designing a processor designed for mobile phone, it should be portable, it should be small in size. So all this what we are discussing, it should be fast in performance, the phone, right? What we are discussing, we are discussing specification, correct? So specification. So whenever you are going to purchase any application, what you ask for? Specification. You have that in mind. I will purchase 6 GB RAM. I will purchase this much of memory. I will purchase gaming mobile. I will purchase good camera phone, selfie phone, right? All these are what? Your specification only. You are seeking this specification. Now whether that chip is able to accommodate those specification or it is a question of designing, right? Whether we are able to realize it or not, that is a question of designing. So ASIC is nothing but application specific integrated circuit. No matter, so there are n number of applications. Now I want to design a chip for a missile, guided missile. So what I should do? So wherever I set the target, it should follow that that trajectory path, and it should hit the target. That should be the goal of that missile. That's all. And it should have a good robustness, right? It should not burn off due to heat of missile. So a lot of different factors are there. Now suppose you have hit the target already decided and missile is launched, and in the middle of air or middle of trajectory you have decided, and that maybe that other enemy party has surrendered. Now still you will hit the missile? No, right? Same thing happened what was in Hiroshima, Nagasaki. So Americans, they have hit the what they have dropped that nuclear bomb on what Hiroshima and Japan, right? But when they had decided and taken the decision in the middle of that, maybe means it was, some people say, means it's not assured, but some people say that they wanted to change the decision, but by that time that decision was passed and bomb was dropped, so they cannot revert it back. Now we have such kind of guided missiles like Prithvi, our Indian missile only, right? Where in the mid-air trajectory only you can change the trajectory of those missiles. Or suppose you have sent the missile and you have cancelled, like, okay, we will not hit the target. So you can change the trajectory to the sea, right? You cannot bring it back to your own country. So you can change the trajectory to the sea. That can be done. That is very good, right? Same thing happens in the space missions also. So space mission, so we say that a manned mission or no manned mission, right? There are no, we are not sending any human beings. So recent was Chandrayaan, right? So we sent rover and other things to test that moon's south pole surface. So in that, if you search, right? So there are few things like so if you search, so in ISRO's website only they have explained that. You can check. So that I want to show you. So this one, Chase 2, right? So if you read here, not this one. Wait. I will find out and I will show you in class also. Right now it will take time. So there are a lot of components in that machine, right? So there was one machine which is meant to drill that Chandrayaan surface. I forgot the name. So it used to drill at some depth, right? And for each depth it needs to collect some sample from that surface area. So it will keep drilling it and it will be telling you about the what is the humidity, what is the moisture level, whether any moisture is there or not, right? And what kind of material is there in that depth. Keeps drilling them. And suppose you want to control that, right? It should not be automated, right? It will drill. Sometimes you will find some rock. We need to alter it. How you will do that? So if it is fixed design, if it is a fixed chip, can your mobile processor, you can alter it to do something else? Wash the clothes, washing machine, can you use your mobile chips? We cannot use because application is fixed. So for such designs like in missiles, for some space mission, where we need to alter our decisions or change something in the mid part only, it means reprogramming it. So that ability is there in FPGA. That is called as field programmable gate array. It is a reprogrammable chip. Whatever you are using, smartwatch, earbuds, or mobile phones, all those are fixed programmed, right? You cannot alter the program and use that chip into something else. It is fixed. But there are chips which can be reprogrammed, right? So those are in form of gate arrays. Those are called as field. So it is also reprogrammable chips are also part of ASIC. You can see this image. So it is an array of gates where these are called as LUTs. You can change into any logic and you can connect according to your need. These are what? All the bus arrays, network arrays, which is not connected. These blocks are configurable blocks. Why we are saying configurable logic block? You can convert into any logic. So this will be defined. You can have some AND, you can have mux, you can have full adder, you can have DSP processor also. And you can change the connections. So you can see bus array is there. You reset it and connect according to the need of design. That is called as reprogrammable chip, that ability. Then we have full custom design. What is full custom design? So now we have two things, semi-custom based design and full custom based design. So you go to market, right, to purchase. So you might have ate that Maggie, right? Have you eaten Maggie noodles? You have eaten, right? Maggie noodles. So when you go to market, what you purchase? You say, give me a Maggie noodle packet. Then that's all. That's all. How you are cooking Maggie? Simple thing, right? You purchase noodle and then only you will tell give me Maggie packet, or you will tell that give me this flavor, that flavor also. That also you will tell. Nowadays we have that atta noodle or non-atta noodle. That also. So how you will cook? You will bring that packet and you will add into bowl, right, of water or something. Then what is the next process? Hey, 2, 3 process only there, right? Why you are so thinking like very complex thing? Then what you do? Not eaten Maggie. Eh? First time hearing what is this new thing. Then masala, right? So that masala is there in what? A packet. What is that masala? It is a ready-made masala. Other way of cooking Maggie, if you give that same Maggie to your mother, what your mother will do? She will take that masala packet out and put it in one box. She will not use it. She will use the trust on her own masala. She will add her own homemade masala into that Maggie and bring some new taste. Right? I don't know, miss, in every house it is happening or not, but most of the time she will do her own experiments. Right? So, what is the difference here? In one, you are using ready-made masala. In second one, it's a lot of effort making this raw masala by own in mixie or some grinder, right? Adding vegetable, adding some extra experiments, and make it unique. So what is the difference here? One is full custom, and one is semi-custom. What is semi-custom? Using that ready-made masala. Okay, that is fast. You can cook it fast, but how good it is if you compare with that Maggie which is made with semi-custom, right? How good it is. Of course, mother's Maggie is always tasty, right? You agree or not? Right? Her experiments always successful most of the time. So that is what. If you cook using raw material, right? Cooking means just grinded, fresh. So that will have its own uniqueness. That is more better. Same way, in full custom, what happens? Design starts from transistor level. Okay, we are not using some standard cell libraries, ready-made libraries. We are not using there. We are designing each and everything from transistor itself. That is very complex. Think about it. If you want to design a processor which has a billions of transistors, you will be like your 3 generations will be gone and you will forget about design, it will work or not, but 3 generations will be gone thinking about the connection, which transistor will connect with what. It is a headache or not. We cannot design billions of transistor circuit. So how we found out what is the idea? So you want to design 8 cross 1 mux. How you can design 8 cross 1 mux? Using 3 4 cross cross 1 mux. Simple. We don't have to think about internal transistor. If you have 4 cross 1 mux, easily you can place 4 cross 1 mux 3 times. You will get 8 cross 1 mux. Why to design all the transistor in 8 cross 1 mux? No point, right? So that is faster. That is a semi-custom based design. Using already designed libraries multiple number of times, right? So that is standardized. Like Maggi masala, if you see, you purchase 5 packets of Maggi masala. Open that 5 packets of Maggi masala. Taste it. How much difference you will find? Almost negligible, right? There will be no difference. Salt or whatever it is there, it will be almost same. That is why? Because while manufacturing that masala, they have standardized the taste. Similar way, the cell libraries, right? It will be standardized. That is why it is called as standard cells. So standard cells are predefined cells or pre-designed cells which have both logical as well as physical information. Means we already have that layout. The layout information is also there and logical timing information is also there. Just we need to use that library, right? It is similar to you're going to library to read electromagnetic field theory or some other subject, semiconductor physics or EDC, electronic design circuit, right? You are not doing all those research work what they have done from scratch. You'll just go to library, take one author's book and you start reading. That is simple, right? All the books are standardized or not to the concept. You don't have to find out and rediscover the concept like mothers do. All those read these every time innovative and rediscovery. Today Maggie taste is different, tomorrow it will be different only, right? So that is called as standardizing. So it is helpful and benefit for production. How? So it is always competitive, right? See, the all the chip designers are competitive. So MediaTek is also designing processor. Qualcomm and AMD is also designing processor. Question is who will design fast? Everyone is working on 1 terabyte, 500 GB, 126 GB RAM. Like that nowadays phones are coming 6 GB RAM, 12 GB RAM, and 126, 256 this one internal memory. So everyone is competitive. So who will bring it first? That is important. Like Nvidia is leading in AI chips. So now no one is competing with Nvidia. Why? Because they have brought it first and they got that monopoly. So it is always a race here, actually. So that is time is very important, and it will also cost you more. The time it takes to design, more you have to pay to the designers, engineers, or cost other manufacturing cost will also come in play. Licenses, right? So that is why the design to make it the design cycle to make it faster, we are more working with semi-custom based design, complex design. But if it is a simple design, like if you want to design a mux, if you want to design a AND gate, or if you want to design a full adder, very simple design, that can be designed using full custom based design. Semi-custom is always used for complex design, very complex design, which has billions of transistors. It's not easy to do with full custom. Understood the difference? Again, this will be taught in course if you haven't understood, but have some brief understanding on what I'm saying here. Okay. So in design cycle, the first stage is very important to decide. The first stage is nothing but called as specification, right? So to start designing anything, you must first decide what should be the specification, what I want from design, what I am designing, whether it is a washing machine chip, inverter chip, or AC chip, that needs to be decided. Okay. Now you want to design some things. So what are the internal blocks it requires, right? Suppose you want to design a processor for mobile. What it requires? It requires a display unit. It requires a power management unit. It requires a arithmetic logic unit to process the numbers, right? It requires connectivity related modules like Wi-Fi, Bluetooth, RF, right? It requires interfacing, right? You want to connect a audio jack, it should process that audio jack, right? It should accept that audio jack. How it will accept? That interfacing module should also be present. Eh, now you want to store lot of photos, lot of datas. How you will be storing? You require lot of memories, right? So sometimes you are playing games. You are playing something like some game, like uh, PUBG or Free Fire, high-end games. And if you are playing just that snake part, right? That snake will eat food every time you need to take. That is a very simple game. So you have two game now. One that snake one you have played, right? That in Nokia phone or something, keypad phone. So what is the difference between that game and the PUBG or that Free Fire game? So in that snake game, graphic requirement is almost nil. We don't need very high graphics in that game, right? Whether memory, what about memory? We require a lot of memory. No, simple small memory will also work. Whether we require a lot of touch and this keypad operation, the processing, we don't require. It is a 2D game. It is not even a 3D game, right? So dimension is almost 2D dimension. It is not a 3D. Then whether we require internet to play that game, snake game, no, not required. Whether we required what we say a good audio video or audio, is there a background sound in snake game? Not much, right? Simple beep sound. Whether we require mic to speak with someone else in snake game, not required, right? And whether we required some sensor, like in car games you might have seen, you tilt your mobile phone, your car will also tilt, right? Whether we require sensor activity in that processor, not required for that game. But if you play game high-end games like COD or that PUBG or that free fire, what we say, free fire, right? All these hardwares are active or not. That is the reason your phone gets heated up, right? You play game for 1 hour, 2 hour, then mother's head and your phone's back will get heated up, right? Why that is happening? Because of more hardware usage, right? If I teach you more 6 hours here, what will happen? Your processor will get, your brain is nothing but your processor, it will get heated up, right? There will be one saturation point you will reach to. Same thing happens for phone also. You keep playing game from morning to evening, what will happen to your phone's brain? It will get saturated, it will get heated up, right? So it depends on hardware usage, right? Based on application we will be deciding hardware. So the major specification here we decide with respect to power, area, and speed. Suppose you are using a portable earphones, right? Do you require a big area of design? You are using big headphone. You don't want that big headphone, irritating headphone, which is hurting your ears. You want soft and small, which can be just cushioned in and you can use it, right? Those are what? Portable. So we need to take care of area, very important, right? Suppose you're using mobile phone, you want your mobile phone to be in night mode, right? It should be very slim trim. It should not have that what we say, what we say it should not have cholesterol, it should not be big fat, very fat, heavy, right? It should be slim trim, easy to handle, light in weight, and good in performance also, right? It should not slow phone them if it is small. So area is important, performance is important, and power. Why power? You cannot keep every time tagged with wire, right? It should be portable. Once you charge, it should work for 2 days. It should work for 1 day or 3 days. So good backup power, good supply should be there. But if you increase the supply, right? Nowadays we are having 0.75 volt supply, 0.95 volt supply. What if you take 5 volt of supply? 5 volt of supply means it's too much. Power will be like anything. It is good for your design that you're getting good power. But whether your battery can sustain it, it will easily drain that power or not. Understanding? 5 volt is a good for your design. You're getting more power, it will work faster, but it will drain faster also. Because you're having 6000 mAh battery, instead of 1 day, it will drain in half an hour. That is why low power is very important. In low power supply, your design must not compromise performance, right? That is why you might have heard, you might have heard whom. So you listen one of the speech of Abdul Kalam, APJ Abdul Kalam, right? He says in his speech that he sleeps only for 4 hours, right? But he also tells what he eats. So he'll be eating not 3 times and eating all carbs and every time not eating. Because if you take eating more, right? So you need more time to process it. Your energy will be utilized more and you will drain faster. You eat lightweight meal, right? Whenever you require energy, you will be very active, very energetic, and you will work faster and sleep less. In 4 hours only, you will feel refreshed. What happens when you eat too much, right? You will immediately, in 10 minutes, you will get sleepy. Why? Because the body requires effort to digest more food. So if supply is more, then what will happen? Effort will also increase by the mobile phones, right? It will use more, drain more, right? So that is what low power is very important. It does not mean you are using low power. You should not compromise performance. Performance should increase with that. Understood? So there are, so we cannot generalize here. So we say that there is a trade-off we need to follow. With this power, how much is the performance? How much area we can shrink? All these are important part. So next is, once specification is decided as per our need, right? Next is we need to design the architecture, right? Architecture is nothing but a block level diagram. What are all blocks required? GPU, CPU, right? Or audio, visuals, and how many inputs are there? How many outputs are there? How those blocks are connected? It is nothing but a block level diagram connection. So if you have memories, processor, and how those interconnects are there, that is what we are defining here. So that is architectural level. Next, once architecture is decided, now you need to design each block. Okay, how motorcycle or how car is designed, completely not designed in one go. So tire will be designed in tire unit, engine will be designed in engine unit, chassis or the body of the car will be designed in that body unit, right? So what happens? Everything is designed separately. In the end, what will happen? Assembling or integration, right? So same thing, each block will be designed separately. For that, for designing, first step is what? RTL designing. What is RTL designing? So RTL designing is designing using hardware description language. You cannot every time design symbolic represent. Something should be defined in terms of code. That code is called as hardware description language. There are many types of hardware description language. Verilog, VHDL. I think many of the college nowadays teaching Verilog also in electronics. So not for CS, but in electronics they are teaching Verilog. You don't need to worry because this comes under front end. RTL designers will take care of. Physical design comes under back end, right? So how they are designing, I'll just give you one small example, right? Let's say mux. Mux has how many inputs? Three inputs, 2 is to 1, right? So how this mux can be designed? It can be designed in many ways, right? So basically, it is written in hardware description language. We have 4 modeling styles to write the code for same design. One is behavioral, structural. Who said structural? Wow, good. So in structural and data flow and gate level. Gate level, or we also say switching level. So these are called as 4 modeling style. So you have to write either Verilog or VHDL. So both nowadays Verilog is only used. Okay. Now out of these the same design can be written in these models, right? Which one is best? Why? Why behavioral? See, I will give you one simple example. Okay. See, data flow or gate level. Data flow means you need to define how data is flowing. For that, you need to have understanding on Boolean expression. That is S0 bar I0, S0 I1. So you know that how data is flowing. So first this is ANDing and then ORing. So you have to write and then OR and one inverter. This is nothing but data flow. We are just defining where from where input is coming and what is the output, and those output will be integrated to get the final output. That is data flow. We are defining the data flow. Structural means each reference library will be defined, and right, what is that label means reference name and the instance name and its connection in terms of pin, and has how many pins? 3 pins, 2 input pins, 1 output, A, B and Y. So A pin is connected to which net? Let's say net 1, right? Then B pin is connected to net 2 and Y pin is connected to net 3. So where is net? Net means wire. Let's say this is wire. So this is N1, N2, N3, right? In next line I can write another and, right? And something L2. So here I will say that dot A pin of this and is connected to N2, right? And dot B is connected to N3. What does this mean? I have another AND where dot A pin is connected to N2 and dot B pin is connected to N3 net. This is N3, right? Then what we are saying, so here we have inverter also, right? So we need to define that separately. So inverter, see I haven't not written for output, you have to write for output also. For inverter, let's say this is label 3, and then we can write Y pin dot Y pin, input pin is connected to which net? N2. So let's say this is N2 and this is N3. So we'll make this also N3, right? Input pin A is connected to N3. Understanding what I'm writing here? So this is structural. How structural, how it is getting connected? See, this is input pin of inverter connected to N3. Understood? Output pin of inverter in N2. Verilog is not there in PD course. You do not require Verilog. This is for understanding the design cycle. Only knowing PD is not enough. You have to understand complete design cycle horizontally. Vertically, you should only learn PD. Vertically means what? Depth. By depth, you have to go through PD. But you should have knowledge of complete VLSI design cycle. Yeah, that is what I'm briefing here. So, question is now this is what structural. Behavioral, you need to define behavior of mux. What is behavior of mux? So behavior of anything depends on inputs. What inputs you are giving? You go to a beggar, right? Who is begging for food or some money, and he is asking something. What you will give? So if you give 50 paisa, right, which is not working nowadays, what he will do? He will throw back on our face, right? You give 1 rupee, that also nowadays throwing on our face, right? Now you bring cook rice and give it to them, right? Many beggars won't accept that also. They're giving it back. You only eat this rice. I will give you more, right? So what is happening? Now you go to them and give 500 rupees note. What will happen? He'll be very happy. Live 100 years. Like that, he will give blessings. Right? What happened? What changed? Behavior changed based on what? Based on inputs. Right? So, based on what inputs we are giving, behavior will change for this function. So, define the behavior based on inputs, right? And you will get what outputs. So, if, right? So if means what? We are conditioning it. If you give 1 rupee, behavior is this. If you give 500 rupees not, behavior is this. Understood? If S equals 0, right? Then Y is I0. Understood? Else if, right? Or if let's say there is 4 is cross, or we'll say else Y equals I1. So this else is for what? S equals 1. Understood? So this is all conditional. So whether you see any logic gate here in my behavioral model, any logic gate is defined, and or inverter, any digital concept is there, any, so but you should have knowledge of digital. It does not mean that you should not have knowledge, but it is easy to write code in behavioral, right? You don't have to get so much of knowledge in digital, and very easy to understand also. So that is why RTL designers will use, majority of times they use behavioral model, right? Here the example you see on right side is a data flow model, okay, of 4x1 mux. Understood what is RTL designing? Next, once this is done, they need to like check the functionality, right? They can check through what? Different tools like Vivado, Xilinx ISC, right? These tools will help them to do simulation on these designs, right? They will give test cases, or they'll verify this design. How they'll verify? For that, design verification team is there, right? So those are checked or verified through test cases. Suppose you have designed something, what we say, suppose you have designed some mold, right, to cook cupcakes, okay, of some size. Now other person, so you have a bakery, right? Now customer comes and he says that, okay, no, we want he or she says we want big cupcakes, right? It should be very big. So now you don't have that mold. So that means that design is not versatile to create all the different size of cupcakes. Suppose you have created cupcakes made up of silicon material, right? Nowadays we are having silicon material based cupcakes. That is very flexible, and you can increase the size also, right? And you can reduce the size. So that option is there. Means it is passing the test for multiple sizes of cupcakes. So which design is better? which passes the design for multiple number of test cases. Like cars, you take one car, right, nano car, and you take another car, Jaguar car from the same company, right? Which one will pass more test, Jaguar or nano car? Why? Because of design is that, right? How design Jaguar is, it will pass lot of tests, accident test, gravel test, there is a road if you have a very sand based road. So the design of nano will not pass lot of tests, right? So it is based on our design is passing how many number of test cases. Now this is one thing to tell. Other thing is functional test. For that we say that it is a functional coverage, how much it is covering. So for that, all the design must pass for all the possible input cases. Suppose 2 cross 1 mux is there. How many possible inputs are there? How many possible inputs for 2 cross 1 mux? 2. So for 3 inputs, if you check the design, whether your design will be functionally correct, possible input sequence. So there are 3 inputs. How many possible input sequence? 2 to the power n. N is nothing but the number of inputs. 2 to the power 3 is 8. So you can generate how many possible inputs? 8 possible inputs. If you check for all 8 possible inputs, your design is correct or not? You will get the desired output. You should get the desired output for all 8 possible inputs. Then your design is correct. And this information is coming from where? Truth table, which tells truth. If your design is passing for all those 8 possible inputs and you're getting desired output, your design is functionally correct. What is the functional coverage? 100%. Why? Because for all possible inputs, you're getting the all desired outputs. Functional coverage is 100%. Okay. So these terms are related with design verification. I have given small brief on this. That's all. So they will do a lot of simulation for each and every inputs. So once verification is done, functional verification or the design verification is done, then comes synthesis. Now that RTL needs to convert into gate level logic design. See, ultimately what is our goal? We discussed, remember, we need to have design in physical world. We are not talking about symbolic or logical. I have shown physical top view and how it is fabricated. That thing, that is our target. That is our, we need to reach there. For that, whether that behavioral code will help us to know how many logic gates are there, how many full adders, how many mux, we don't have idea, right? For that only we require synthesis. Synthesis is nothing but breakdown of complex code into gate level design. What is photosynthesis? You might have studied in schools, right? What photosynthesis does? So during sunny days or in presence of sun, what it does? It does photosynthesis. In presence of photons, it does synthesis. What it does? Internal to leaf. Forgot. Got 95% marks. Done. My biology is over. No need to study. What happens next? So it starts breaking down what? Glucose, correct. And it generates energy from that glucose. Breaking down of complex carbs, complex glucose is nothing but called as synthesis. Breaking down of anything is called as synthesis. You eat food, you chew it, break down into some particles, right? And it goes inside and in contact of acid. Again, it breaks down into small particles and it generates what? Energy from that. From that glucose, it tries to bring it into bloodstream. That is how it is absorbed. So breaking down complex things, right? Or carbs or glucose or RTL code. It is a complex code. It's a behavioral code. No gate information is there. You need to break down into understandable logical gates. So we call it as RTL synthesis, logic level synthesis. It converts RTL code into gate level netlist using standard cell. You remember what is standard cell? Ready-made masala. Forgot? It is standardized. So it is dependent on technology node, right? Why we are saying dependent on technology node? Because those standard cell libraries are technology dependent, where when I have said both logical and physical information is present for standard cells. Physical information, once that physical term comes, remember that it is technology dependent. It has a size, it has a width, it has a length, it has a layout, right? So that is why we are saying that synthesis is a technology dependent, because those libraries are technology dependent. Clear? So this is a synthesis process. The code will be converted into gate level connections. So basically, gate level netlist is nothing but a format of structural modeling. So it is converting the behavioral code to the structural modeling code. That is why I have explained what is structural, what is behavioral, so that you understand this conversion. Okay. Then in synthesis stage only, we will do in synthesis stage only, we will also insert DFT module. DFT is nothing but design for testability. We also need to improve the testing feature in design itself, like MBIST, memory built-in self-test, or ATPG, automatic test pattern generator. So these are what? Self-testing ability. So if you have a billions of transistor, if any interconnect fails, giving wrong results or goes into metastable state, how you will identify in that billions of transistor? You will open the circuit in microscope and you will find out where it is going, where even though you get the wrong output, you cannot track back to that net, right? It will be somewhere in 1,000 levels. How you will find out? So for that only we use DFT. We insert these scan chain logics inside the design so that those faults can be identified. It is called as stuck at fault, stuck at 1 and stuck at 0. So if you choose DFT as a field, you will be learning more about how these logics are created. Okay. So the first stage from after this, your physical design will start. The first stage of physical design is floor planning, right? So till this point, logical design is completed. Logical verification is completed. Conversion of RTL design to the gate level netlist is also completed. So all logical part is completed. Now we need to start physical implementation of design, right? So the first stage. So now it's similar to building a house, right? You started building a house. It started from what? Idea. Your parents sat together on dining table and deciding we will build some good house, right? That is the idea. Then your sister will say, I want this room, my room color should be pink color. Boys will say, I want PS5 in my room, right? One bike photo on the wall, right? Some specifications, some requirements are there from kids, right? Or your siblings. Then parents will also have the requirement. Even the wife will also have the requirement. All those requirements should be taken into an account, and then you will decide what should be the plan. Then you will bring an architect and you will tell to design, we want interior garden, terrace garden, vegetable garden, something she will ask, right? So based on that, you will tell architect, we want this thing, we want this thing, we want this thing, and then you need to design, and you will give suggestions, right? So architecture will be designed. So that is all what? Idea based or logical based, symbolic ways. That is not physical implementation. Then once that is ready, okay, then you will start what? Physical implementation. What is the first step? Floor planning. No. First is purchasing a plot and deciding the area. So you have decided to build a mansion, right? And you are purchasing a plot of 1200 square feet. What is that? 1200 square feet, right? Whether it will be means sufficient? No, right? We need a big cricket ground like space to build a mansion. So based on our design, you need to decide area, right? Power and performance. So first thing important physical parameter is area. How much length and width of boundary should be there, right or wrong? Right? The shape. Suppose sometimes you want L-shaped building, right? L-shaped building, like you are constructing a school. So you want to construct a L-shaped building. So the shape of boundary is L shape. You have to decide area also. Then what is the next step? Compound walls. If you do not design or build compound walls, it will be captured by someone else. You need to protect it by designing or by covering it with compound walls. So that compound wall is called as die area or die boundary. The first compound, the first boundary is called as die boundary. Second boundary is called as core boundary. Why core? From there onwards, you will start building your house. See, you will not start building your house immediately from the edge of your plot or not. If you do that, other person will also do that same thing. Then whatever you are cooking and whatever you are talking, that neighboring house will able to listen, right? So not for that, of course. Then there will be like there are some rules also, right? You need to leave 1.5 feet or something like that, so that that interference should not be there. So interference, to avoid interference between block, we leave some space between die boundary and core boundary, right? That space is called as core offset. It is not written here, but it is called as core offset. Inside core boundary, now you have designed die and core. Then what is the next thing after constructing compound? You need to create gates also, right? Where will be the entrance? Where are the exit points? So suppose you are constructing a mall, you need to create multiple entry point, multiple exit points. Suppose you are building a college compound, there should be multiple entry points, multiple exit points, right? You need to create ports in design, from where inputs will come inside, from where outputs will go outside, from where power will come. So ports will be placed in boundaries. Next, you have this core area. This is called as core area. Inside that, now you will start constructing, right? So you will start constructing. How you will do? First is building a foundation, and foundation you can build it by the major blocks. So you'll build a foundation. Foundation is ready. Core is ready. Okay. Now you will start placing what? Partition, right? Partition of what? Hall, rooms, kitchen, bathroom, right? All these you will create or not? That is called as partition. So first hall is partition, then your other rooms. Based on room, specification will also change. So CPU, GPU, display, this Bluetooth, audio, all these are what? Rooms, blocks. Now each block has separate specification and you will design separately. So each block, suppose this is one block, block level floor planning. So each block now you will pick and you will create walls or something like that, and it is created. Now what is the first thing you will be placing inside home? So it is created. So partition and blocks created, walls are created. Now it comes placement. Everything is created. So painting and all is done. Now what is the first thing you will place inside home? My accessories, right? My shoes, huh? My bike, correct? Then we never went for Graha Pravesha. Huh? In Graha Pravesh, what they will do first, what they will like place, big things or small things? Big things like what? Almira, TV unit, or washing machine, fridge. Or they will say, hey, my dress is missing. I should bring my dress first. That should not get missed. Where is my dress? Right? Or where are my accessories? So first thing is we will bring all big objects inside our home, and you will place it somewhere here and there. You will not rearrange it, right? You will place somewhere here and there. Then you will decide or not where I need to place it, right? Fridge, where you are going to place? In drawing room, right? And TV, we will place it in kitchen, correct? And in bathroom, we'll place stove. That's right. So some kind of functionality we need to take care, like whether it is suitable for that block or not. If display logic, memory logic is there, why we need to place it in audio? That much of memory is not required. So depends on our block also, whether requirement is there or not. So fridge, you will take it to kitchen and you place it there, or in your dining room, you will place it there. Then the dining table, you will place it near to kitchen, or if you have a big kitchen, you can place it inside also. Then TV unit, you will place in drawing room or your hall, right? Bed is also big object, you will place it in bedroom, right? Almira and all this. So you start rearranging it based on what? Based on its usage, based on its connections, right? See, kitchen is somewhere here, and you will not place dining table somewhere far from kitchen or not. You will try to place it near to kitchen, nearest to kitchen. Why? So suppose you have cooked something, you don't want to carry it to some far place and you keep it. You have to just cook it and keep it on dining table. That's all. So that is the good way, right? So connection is also important. Same way, the macros, the bigger blocks are called as macros. To place macros, we need to think about its connection, whether those two are connecting and talking to each other or not, or those two macros are related or not. So that is why we say that we follow some sort of guidelines, right, to place macros, bigger objects. Okay. Then we also create power domain. See, all these macros, bigger objects, does not require same amount of power. Whether your CPU and audio require same power? No, right? CPU is always active. Clock cycle is every time keeps on ticking, right? So it requires more power. Audio does not require that much of power unless and until you are using mic or listening music. It does not require that much of power. But CPU is continuously switching on and off, right? Clock cycles are, even if it is in idle mode, mobile phone is still working, right? So CPU is nothing but heart of your design. Okay. So it is your heart is what? It is nothing but clock. So in certain frequency, it's keep beating, right? You run 100-meter race. What will happen? Heartbeats will increase, means more usage of energy, more usage of design. You play PUBG game, you require faster clock cycle. The slower clock cycle is there, you cannot play PUBG, right? More usage of hardware. Understood? So like that, based on that, we'll be placing macros, and based upon power usage, we'll be creating voltage area also, right? And there are some physical cells, cap cells, end cap cells, those will place. So blockages are, suppose somewhere you don't want to place some object, you can block it, right? Like you know that you have a kid, and that kid can fall and get hurt by something else. What you will do, you will block it with some protection or something, right? So we don't want someone to go there, so it is called as blockage. So if you apply blockage in design, no cells can be placed there, right? Or some cells can be placed, so those are called as blockage. Then you will be doing electrification of your home or not. So power supply is also important. All the logics, right, should get power. So at home you will be placing, you will be creating power grids. You can see in this room also the power lines are there, right? PG lines are there. Both VDD and VSS are flowing throughout the room. So to have better connectivity or short connectivity, power line creation should be very important, right? Suppose your TV is here and you are making that plug point somewhere opposite side. So how much wire length will be there? From here to you have to make it till the end, right? What will happen? Wire cost and resistance will increase or not? So that should also be taken care. Very important. IR drop will increase if you increase, if your grid is not proper, VG grid is not proper. Okay, then comes placement stage. Once all major memory cell, macro cells are placed, you need to place all the standard cells. So we have discussed this. What is standard cells? Basic building blocks or predefined cells like AND or other logics, inverter, XOR, full adder, MUX. All these are small basic blocks. So these can be placed here. We are not talking about connectivity here. Just we have placed based on its family, right? So at your home, you have built your house, right? Now you will be placing, you are shifting to new home, right? Whether you will shift your neighboring people also in your home, you will only shift, right? Your brother, your sisters, and your parents, you will shift, who are relative, or max case your relatives, right? But you will not bring neighbors also and you also stay in my home. That won't happen, right? That if that happens, then area is not sufficient. So same family groups will stay together, right? What happens if your brother goes into neighboring house and starts staying there, brother or sister? What happens? Then your mother calls for a dinner or lunch. Come, do lunch. How she will call? It's a communication problem, right? There is a big communication problem if same family group members stay away from each other, far from each other. What will happen? It's a very difficult communication. Delay. There will be delay. If your brother sister is near to you, studying with you, immediately you hey, tell them we'll go for lunch, we'll eat food, like that you will tell or not. So delay is, so placement is very important. You should group cells based on its hierarchy. That is called as family grouping. So after this, you should also check congestion also. Suppose in same room we have 100 person capacity, right? 100 people capacity. If 200 people comes in this room, what will happen? There will be no place to sit. Lot of congestion, right? So you should also take care of congestion. If you over area is overutilized, then it will lead to congestion also, right? Then once this is done, we also know in some of the standard cells we have flip-flops also, and that requires clock, right? Now it will be not in some numbers, it will be in lakhs, right? All those sequential cells needs to be get clocked. If it's not properly clocked, what will happen? Delay will be there, timing will become bad, performance will become bad. What will happen if it takes a lot of time to for a clock to reach to a sequential cell? Your latency will increase. What is latency? It is a delay only, right? If the delay is more and that wire length is more, what will happen? Transition time will also increase. Transition time means clock pulses are continuously getting transited from 0 to 1, 1 to 0, 1 to 0, right? To get that transition from 0 to 1, it will take time or not, if that wire length increases, right? That is why clock routing is also very important. All the cells will be supplied by intelligent clock structure. To have that intelligent clock structure is the stage which we call it as CTS, where we try to target and reduce skew and minimize the insertion delay. Insertion delay is nothing but latency, right? So in order to reduce power and timing. Understood how it is reducing? We will go in more detail once we are there in advance. Here we are deficient of time. I cannot explain in one class everything. That's just briefing. So once your power routing is done, clock routing is completed, what is the final step? All the blocks should be connected together. All the standards should be connected. What should be connected? Data signal. So any cell, any sequential cell have how many types of pins? Data signal pin, clock pin, and power pin, right? Power is routed in power planning, in floor planning. Clock is routed in CTS, and routing will be done in final step. Data signal routing will be done in final step. That is called as routing, right? Here also you should take multiple number of what we say challenges. Like you should not get short with two different signals, data signal. What will happen if data signal 1 and data signal 2 get short? Functional failure, right? Functional failure or not, if your AND input is getting short with another AND input, what will happen? Functional failure. So that short should not happen while doing physical routing. Now it is in multiple metal layers, so anything can happen, right? So that is one example. So you should also check DRCs. So when we talk about routing, you have to take care of manufacturability or not, whether it can manufactured or not. So if two metal layers are there, right? If there are two metal layers, if those metal layers are routed very close to each other with minimum spacing of 0.01, but Foundry says that we don't have such mask. Remember mask? I have told what is mask. We don't have such mask with this spacing. We have mask with the spacing of minimum 0.06. So they are telling us a rule which is called as minimum spacing rule for, let's say this is M1, this is also M1. They're telling if you are routing M1 metal layer, use at least 0.06 micron. Don't go less than that. If you routed less than that 0.01, what will happen? Minimum DRC violation will come. That is a violation. It means, in other words, it is trying to say that we cannot manufacture it. If you go to a carpenter and you tell, I want 100 feet bed, what carpenter will tell? Go back home. I cannot design this. I cannot create this 100 feet this thing. So because it is out of its manufacturability, it cannot be done. So carpenter will, then you will ask how much you can build. I can build 6 feet, 7 feet bed. That's all. So he is giving you what? Constraint, rule, restriction, right? So that you need to follow. You don't have any other option. Foundry rules cannot be changed. You have to follow that physical constraint. That's all. So those all things is taken care in routing, and then we have sign-off steps where timing, power, and physical verification is done. All this. So in timing, you need to meet timing constraints like setup timing, hold timing, transition time, right? SDC constraints are there. You need to meet it. In power, you need to meet EMIR, electromigration, and voltage drop should met. These all constraints should meet. Then comes your physical verification. You have to do LVS check. DRC check, function. Then we have LEC and CLP cleaning, right? So that is logical equivalence check. Logically, see, after physically routed also. What we have designed in logic, we don't know architecture. Where if that Mistri, what we say, the builder, if that Mistri is not experienced enough, you wanted a kitchen garden and he built some garden we don't know, then you will be like angry on him or not. Hey, that is not in design. What you have designed bathroom on terrace. We didn't told you to design that bathroom on terrace. So what is that? Physically, functionally not correct. In design, it is correct. So after physical routing is done, physically placed, you should also make sure functionally it should not change. Right? That will be checked in LVS, and the logical equivalence check also will tell you. Then DRC I have already told one example, that is mean spacing rule violation. Okay. So these are the tools which are used for different stages. For layout, custom compiler and caliber are used. Synthesis design compiler. Okay, this is from Synopsys. Placement and routing ICC2, which is from Synopsys tool. Spef extraction is from Star RC. Prime time is for STA. And physical verification, we have caliber and ICV. These tools are used. Right, power sign off, prime power and red hat tools are there, which is voltas is from cadence, which is used for power sign off. Okay, so this is the basic, what we say, physical design flow. Right? This is nothing but the physical design flow, advanced physical design flow, and the complete starting from specification what we have seen, right? So I can take you there. This one. So this is a physical design flow, and the first one. Yes. So this is a ASIC design flow, complete design cycle. Till RTL verification, it is all called as front-end designing. After that, it is all called as back-end designing. So it is in two parts, front-end designing, and so from synthesis and placement itself, floor plan itself, we say that it is physical implementation, right? So in the end, sign off is done. So we'll say GDS2 file is sent to foundry, and then packaging, testing, and then chip will be fabricated on wafer. That is all. That is what complete design cycle, right? Now I am open for questions. If you have any doubt or question regarding technical subject, course structure, or placement, or anything else, you can ask clearly, or timing, right? So you can ask me any question. So I'll be taking questions from you. PPT you can take from management Vikram. They will share it with you. Fees related questions you can ask from management. I'm here for technical assistant and course assistance, like whatever related to course placement, timing, class, and how placement process will happen, what we will learn, what are the topics, all those questions you can ask from me. I will answer freely. Sir, are we learning language in this course? Yes, we will be learning one language, that is TCL scripting, tool command language, which will be helpful in your physical design only. So we'll teach you from basics, TCL scripting. Sir, I have enrolled for 8-month course, but according to your schedule, it will be completed within 6 months. Then what about 2 months? See, 2.5 months will be for basics. We are telling time, usually whatever time we are telling, 6 months. It is the Minimum average time we are telling. 8 months is the worst case scenario. Sometimes the trainer is not available, sometimes, not every time. Or sometimes what happens, the batch has a slow learning pace. So with respect to the batch, trainer needs to adjust the space also. Sometimes batch only will not come, right? What happens? Then delay it. So that is 6 to 8 months, right? So that is stipulated time, not the fixed time. If everything goes fine, batch is also fast learner, fast grasping. Okay, everything going fine, then it will not take more than 6 months. Sometimes if I am there, so I will take some extra time. I will take lot of experiments. I'll discuss real based scenarios. I will also give you lot of my assignments also, task based assignments also. So that will sometimes extend the course. So it depends on trainer to trainer and depends on the batch response. Placement process 100%. See, in this world, 100% is nothing. You also know that, right? It is only having the dependencies. If that dependencies are fulfilled, definitely it is a 100% placement. First thing is whether our input is there or not, right? That you should ask yourself. Second thing is whether our input is there and it is enough or not. That you should ask second thing. Third, whether whatever I have planned and decided and able to complete daily basis or not. So whatever you have planned, right? Whether it is in action or not, that is third thing. Only three questions you need to ask. You should not ask, means you should see, of course, but you should also see opportunities are there or not. Don't think while learning. I will say this is my opinion. Means of course you should look for opportunity also, but in initial learning period, your focus should only be inside learning only. How much I can learn. That's all. After that, once opportunity is there, whenever it is there, right? You will be ready to take that. But if you keep on thinking on opportunity will come or not, 6 months after there or not, you cannot focus on present, right? You cannot work on daily basis on action. You will feel anxious, right? You should not feel anxious. While learning, you should be very calm and composed. Then only you can cover all the topics and understand also. So yes, if you follow all the placement process which I have explained, attending all the sessions offline if you can, right? Next, giving all the tests after each stage, taking all the assignments, solving all the question, writing answers by pen paper method, right? Of course, you can use, there is no restriction. You can use soft copy also. You can write on Word also. But I suggest that you use pen and paper. That is more good for your learning, right? If you do that, then what will happen? Will you mock interviews? Your communication skill will improve. If you follow the process, ultimately no matter what is the result, you will definitely improve. That is for sure. And when there is opportunity, you will shine. You will not miss that opportunity. But if you haven't, so I've seen those students also not studied like throughout the course, not coming properly, and assignment copying from here and there and pasting and submitting. Test also copying answers from other student and giving answers. So you can see how truthful that process is, right? So untruthful process will give you untruthful results. Truthful process will give you truthful results. It's a simple thing, right? So it all have dependencies on your input and the how sincere you are. Sir, is placement step done manually or block or placed automatically? Floor plan is manually done, but placement is automatically placed. So it is called as auto PNR also, auto placement and route or auto placement. So it does not mean that we are not controlling it. So control is in your hand. Where we are going to place certain logic is in your control. If something goes bad, congestion is there, you need to solve it manually only. or you need to drive it. So it is not just push button. Just you have press start, placement done. No, not like that. There are challenges. You need to meet timing. What if there is a more delay? You need to think, right? Why I am getting more delay? You need to find out. You should be having very strong debugging skills. It is not coding subject, of course, but you should be very strong in concept, and you should be very sharp in critical analysis. So it is basically subject of critical analysis, whether you are able to find out, pinpoint the fault or root cause or not. When did course will begin? Okay, so I don't know the next date. Maybe it is in 1 week or 2 week your course will start. It will start from the basic subject. It's not recorded session. That's why I have it is a recorded session, Vikram. So I have told each and every session will be recorded and uploaded. So you can ask for recorded session also, Vikram. There is no issue. 100% written on website, sir. Of course, 100% will be written. That's what. If you suppose you don't study anything, you just apply for this course and go back home and sleep. Whether anyone can give you placement, practically speaking. So I'm not here to tell you some fairy tales, right? I'm not here to tell you that okay, you will get 100%. I'm not telling you what is practical thing. I am telling you straightforward, right? You also know that you are graduates, right? For any exam, semester exam, if you do not study full semester, one night you can cover all the units. You will not sleep. Of course, some people not sleep and will directly go to what? Exam center. What happens? Dizziness, right? Heavy head, confusion. You will write some other concept answer in some other question. So the thing is, the input is not there. You cannot see the behavior. Like I said, the beggar thing, right? If you don't give input, there is no behavior. You give 50 paisa, there is some behavior. You give 500 note, there is some behavior, but it will be there. So based on your input, you give 10% input, you will get related to that input. You give 100% input, you will get output related to it. You give 200% effort for input, you will get accordingly. In this course, we are going to learn both tools or only one tool. Yeah, both tools will be you will be learning. First will be ICC2. You will be doing your projects on ICC2. Then Innovus support will also be given to you. So you will be understanding Innovus tool also. Okay, Siddhartha. Aishwarya, sir, will there be individual assistance to us? Individual means I think you are pointing out that it is one-to-one session, right? For one-to-one session, there is additional charges. If someone thinks I want trainer's personal attention or one-to-one session to clear my doubts, for that there will be additional charges. And if you are asking whether we will have doubt session in group, so that is not chargeable. Okay. So if batch has a doubt, lot of doubts in some topic, so we will be arranging a doubt session also separately. Okay, for revision. uh, Arun Sai Kumar. How many fresh ECE graduates from last batch got placed and which companies hired them? The actual number I do not know, Arun Sai Kumar. So you can check with the manager here, right? He will have that complete list, which guy got in which company or which placement. He can answer that. But yes, see, I can tell you, I can answer one thing here in this question, that there are MNC companies like Wipro, TCS, Infosys, or what we say, HCL, right? These companies nowadays hiring VLSI engineers in bulk. Not in bulk means not thousands. Like they are hiring 50 or 40. That is more than enough in VLSI. Usually VLSI hiring is always single digit only. You might have heard from your brother, sister, or friend who is working in VLSI. You can check with them. VLSI hiring is not like mass hiring, which is Don't compare with the IT hiring or the computer hiring. There they will bring truck in college and they will bring everyone, come in truck. So you also know that 400, 500 people will be hired in one go from one college. They'll pick mechanical people also, civil engineer also, and they will do coding, C, Java, all these civil people are writing. I have seen my friends also writing. Mechanical people are writing Java, C++, these things they are learning. So understand that it is, don't try to correlate with the IT field. Here VLSI hiring is always not like mass hiring like in IT. But bulk here means 50 or 100 is okay, not more than that. That also I told MNC is higher in that numbers, not service based companies. So basically, companies are divided into three categories: product companies, service companies, and what we say MNCs, right? Mass or we bulk hiring type companies. So it is divided into almost three categories. Product companies are the companies who are involved directly in product, deciding the product and selling the product, like Qualcomm, AMD. These are the product companies. Service companies are like Mirafra, Infosys, TCS, Insemi, right? Or these companies are called as service company. Siddharth, what you want me to explain about tools? Like which tool? Neeraj, cadence or synopsis, which tool will be used more by trainer? See, both tools are similar. Okay, both are used for designing same thing. There is no difference in tool except some features, some button display, right? That's all, and way of usage. So if I take two tools in parallel designing same thing, you will get confused or not? Confused, right? First, you learn one tool, complete the design starting from placement, CTS, and routing. To understand the flow, very important, right? You will understand and master one tool, and then other tool will be very easy to understand for you or not, because you don't need to put your brain on design flow. You already know it. You have worked on it on one tool. So first tool will be taken, and then next tool we will give you sessions. Sir, in which month, Chaitanya, sir, in which month will be course will be started? Okay. I think usually after demo session in 2 to 3 weeks, they start sessions. In my experience, what I've seen. But you can check this schedule what is the exact date, you can schedule, you can check with the manager. Will this course cover STA? Yes, STA also I will teach, Srinivas. So STA is nothing but static timing analysis, which helps to understand timing for each and every timing path. Right? That also I'll teach. But STA will not be that in-depth STA I won't teach, but I will cover all the topics in STA. So in-depth STA is for STA team, not for us. So we are just learning STA to understand how timing works with placement, CTS, and routing. That is why I am teaching STA here. How many projects, Hemant, how many projects throughout the course, and which nanometer scale are these projects? See, we have 28 nanometer, 14 nanometer project, and recently we are working on 5 nanometer project also. So initially, 28 nanometer and 14 nanometer project will be followed. One project only will consume lot of time. I have seen from past batch for floor planning only. So trainers should not run away, right? They should see that whether the lab trainer should not run away. They should see that whether batch is coping up with or not. They're grasping or not. See, the trainer can go till routing in one day only, but you should be also able to do or not. You need some time or not. So it takes time for a complete project, at least for the first project. Okay. Minimum CGPA for placement eligibility, Aditya. So Minimum criteria, I haven't seen nowhere defined that six pointer or 5 pointer. Nothing I have seen. But there are some companies which have such kind of policies that they want 8 pointer. Like if you go in Google, so Google has 8 plus or 8.5 plus criteria is there. So there are different companies and they have different, but most of the time there is no minimum CGPA eligibility criteria is there. But if you have like a 6 pointer, right? So it is good enough, I think. If you have less also, 5 to 6, that is also fine. But provided that you have to give 200% effort, what a 9 pointer will give effort, you have to give 200% of that person. Understood? You have to be exceptionally strong. You have to show that 9 pointer will have that upper hand because they will not see that much. Okay, he is having good score, but of course he will also go through same screening. That does not mean that he will be okay. Come. Not like that. He will also be tested. He or she. When's new batch date? You can check with manager Devraj. Neeraj, in Cadence, which technology node and synopsis, which technology node will be used? I said 14 nanometer and 28 nanometer will be using. Will the syllabus teach by you and the syllabus in the website will be same? Yes, syllabus will be same, whatever it is. See, when I will be adding some new concept also, right? Not concept, which is in line with industry. What is going on in industry? I will be telling you that also, how it is designed. So sometimes that topic will not be there in syllabus, right? That new thing will not be there, but I will be telling you that also. Neeraj Kumar, in weekend, how theory and practical will be completed in 2 days? See, for weekend batch, Neeraj, first morning session will be for theory. If it is afternoon, then lab will be happening on morning. So first theory and then comes lab session. 3 hours theory, 3 hours lab. So it is total 6 hours theory and 6 hours lab, right? So that is why weekend batch are usually extended batch. So it will not complete on 6 months. Sometimes it gets extended. Do you provide any course material? Yes, we will be providing you course material also, not only soft copy, the hard copy we will be providing you. So in that course material, you will have digital printed notes, CMOS printed notes, and I think tickle scripting notes also will be there. GVIM notes will also be given to you, and the PD advanced notes will be, theory notes will be given to you. Apart from that, printed assignment notes, printed assignment questions will also be given. In that printed assignment questions, it is segregated based on theory question and lab based question. Both are there. So it is a printed format. Okay, you can learn and you can keep it to yourself whenever you want. You can use it. Hemant, is lab access through VPN available 24/7 only during lab session? Lab access, good question. Lab access will be available for 24/7, right? You don't have to worry when I can use nothing. You can work on night 3 a.m., 2 a.m., 1 a.m., no problem. Saturday, Sunday, Friday, every day you can work on. So lab access is there every time. Srinivas, sir, I have enrolled for 8 months course, but according to your schedule, it will be completed. Same question, right? See, I said right. It is 6 to 8 months. Depends on trainer and batch response. Batch response is fast. Your batch will complete at least in 6 months. At least. If batch response is slow, pace is less, then it takes 8 months. Depends on trainer also. Sometimes we will discuss more, explain more. We'll give some more task. So that will also extend sessions. It is not fixed time that we will go by, we complete. We will not run away that we'll complete by 6 months only. Our goal is to make you learn, whether you have understood or not. It is not about time. So whatever you require from us, right, we are there to help you. What are the opportunity of PhD thesis submitted student? This Neeraj, I am not sure that I can answer this. So because it is PhD, so there should be some level of innovative thing should be there, and you might be publishing papers. And the projects which we are following, it is a institute course project which is meant for learning. There is no innovation. It is a old project only, right? So PhD thesis, if you want to submit, there should be level of innovation or at least some level of new findings. So in this project, you cannot do this because it is a open source, right? Siddhartha, on weekend only theory is for us, right? Not lab. For weekdays people or regular people, there will be no lab session on Saturday, Sunday. Only theory session. Friday will be holiday for you for regular batch. Siddhartha, if I choose weekdays classes, Monday to Thursday lab, and Saturday to Sunday only theory. Yes, correct, Siddhartha. For regular batch for weekdays. Vikram, I have passed out 2016. Will get opportunity. Yes, Vikram, you will get opportunity. Even if you passed out 2016, there are a lot of opportunity for you in service company. You should try for service company. You will definitely get into any one of the services. So you are a MTech or BTech? So this 16 is a MTech or BTech person. Sri Ram, if want to change my domain after 2 months, will that happen? So it is very rare. I have seen someone changing the domain, but I've seen those cases also very rare. But people changing domains. Okay, but thing is, you will be, yes, it can be changed. There is no issue in that. Hemant, any insights for those who are currently working in different domain and switching domains? How would it affect placements? Switching domain means Hemant, are you in already in VLSI? So you should clear that once. So do you want to
Sir,
switch domain? Or so you are currently in which domain?
hello.
Yeah, yes, Hemant, you are in which domain? Yes, Hemant, am I audible? Yes, you can switch domain. If you are already working in VLSI, suppose you are working in front end design verification for 2 years and you want to come into physical design, yes, you can switch the domain provided that you will be joining there as a fresher, right? So your 2 years, of course, that experience will be counted in VLSI, but it won't give that much of impact in PD.
Hello. Sir, am I audible now?
Yes, yes, you are audible, Hemant. You can tell.
Yes. No, I'm in a different domain, as in network engineering domain.
Okay.
Yes. So
Is
how
it a
will that
front
switch?
end?
No, backend.
Is it related to VLSI?
No, it is
Oh, then,
IT.
then, that experience won't count for you. Okay, so you will be treated as fresher only in VLSI. Okay, Neeraj, I am asking a student who have completed PhD now want to work as PD engineering. What are the opportunities? Okay, so PhD you have completed in what? It depends on that. If your PhD is in line with VLSI topic, then you have lot of opportunities, Neeraj. Vikram, BTech. Okay. Yes, Vikram, you have opportunity. Don't worry. Yeah. Any other questions from offline or online? No question. All doubts clear. So I hope you liked my session. And if you have any further queries, you can ask in management regarding fees and timing. I hope we meet again. Thank you, everyone. Neeraj, PhD, if your PhD is in VLSI, then it is very good. You will get lot of opportunity, Neeraj.